Hello everyone. In this video, I'm going to show you how to use the transmission line together with a shunt short circuit stop to match low impedance. So suppose you have a reference impedance 50 ohm and your low impedance is 60 minus J80. So in other words, to normalize the impedance is 1.2 minus J 1.6. So in this kind of problem, you probably already know it. We have a low here, and this low has a normalized impedance, small letter z of L. And we are going to use a feed line to connect directly to the load. The length will be found out in this task, in this video. And finally, we will use the short circuit stop to cancel the subsistence, the imaginary part. So after doing this, we will have a admittance here, y equals to 1 plus something. I don't know, 1 plus something. And then we are going to use a short circuit stop. This is a shunt stop to implement it until we have got y equal to z equal to 1. So this is our job. So we are going to start now. The very first thing that I need is to locate the point where the impedance is 1.2 minus J 1.6 from the Smith chart. So 1.2 is here. So I will just scan it down. Minus J 1.6. Minus J 1.6 come from here to here. So in other words, here is the point. I will label this one A. And meanwhile, I will also label the origin as O. The next thing that I'm going to do is to draw a circle, and this circle is called SWR circle. The center of this circle is right at the origin, O here. And the radius is OA. So we are going to draw this. So this is the SWR circle. And in this circle, the magnitude of the coefficient is constant. Now, the next thing that I will need is to draw the line OA and extend the line until I reach the outermost circles. And from here, I will look down the position. According to my reading here, the position is 0.315 lambda. Now, drag along the circle until you reach the circle, so-called 1 plus JB circle. So 1 plus JB is this circle. 1 plus JB circle. And remember, we have already done this step last time, but last time we chose this point to determine the length of the feed line here. But I have already told you the length can be determined by this point as well. Altogether, you will have two solutions. So we will do this. We will drag along the SWR circle in a clockwise direction. The starting point is A. We always use clockwise direction. And we don't stop here. We'll just continue. So here we go. We meet the point here. This point is, the impedance in this point is 1 plus, according to here, minus, actually not plus, right? Minus J1.4. So in order to cancel this minus J1.4, we need to choose an impedance choose the admittance of the stop that will give us positive 1.4J. So if I start from here, this is 1 plus J 1.4. And we will start doing this here. We will scan this link here and all the way down here. So clearly, you got the position here 0.4 lambda. What it means here is you need a short circuit stop to visualize this positive J 1.4 lambda. But unfortunately, this time, the question asks you to use short circuit stop. This means you have to start from here. This is where the start is. And then count in a clockwise direction all the way the whole circle to here. So I will do this. So here we go. So this is 0.4 lambda. So the length here is 0.4 lambda. The length for the first transmission line can be calculated from this angle. Yeah, the angle counting from here. Actually, from here, kind of up to here. Yeah, sorry about that. So you will count with the angle 0.15. So here, let's see the angle 0.08. So counting from this point all the way here to here, the length will be is so 0.13 and 0.5. So the length here will be 0.5 minus 0.315, and then plus this length plus 0.08. So this is the required calculation that you need. Let me check the calculation. It's 0.5, so 0.5, 8, and then 1. Plus 0.08, so 0.319. So it doesn't make sense. When you use half circle, it should be at least 0.25. Let me double check the calculation. Here is 0.35 lambda, and here is 0.08 lambda, and 0.5 lambda minus 0.4 lambda. It's around 0.26. So it is 0.26 lambda. So 0.26 lambda. So the solution is here. This length is 0.26 lambda, and the short circuit stop will be 0.4 lambda, and this is done. So this is the suggested solution. And by looking at here, the impedance and the admittance is 1. If you have any question, please leave your question to the comment section. Thank you.